takes its time. But that check outside the grades, you know what I'm talking about. Just let me know if you wanna go to that home called the range. They got a lot of nice girls there. Have mercy.
Okay, good afternoon. Today I'm going to be showing you about in Algebra 1, Chapter 10-6 and 10-1, Part 2 of the Trigonometry, and the only part of the Pythagorean theorem. So number 1, if I had this problem here, where I got my triangle, here's the right angle, this is the x, this is the 70, and this is 18. That's in degrees. So a reminder that, when you're doing these, I like to start with these over here equals opposite, the three ratios, opposite over hypotenuse, cosine is the adjacent over the hypotenuse, and the tangent equals the opposite over the adjacent. Okay, and first thing I like to do is identify my three sides. I'll make that a y because I got all these x's over here. So my three sides, with regards to the 70 degrees, that's opposite. This one will be the adjacent. This would be the hypotenuse over here because it's opposite the right angle, okay? Those are some ways you might remember that. So anyway, I don't need the hypotenuse, I need the other two, which means the only one that has the opposite and the adjacent in it is not that one, is this one, the tangent. So I'm going to be using the tangent, and the angle always goes next to the, in here for the x, whether it's sine or cosine or tangent. And then I'm going to plug in my values, opposite and adjacent. So the opposite is the 18, and the adjacent is the y. Now this one's different than some of the ones I showed you in the previous ones because the variable's in the denominator, okay? Which changes things around some. When the variable's in the numerator, life's a little easier. If I take tangent of 70, and I'm going to go into some tables here for a moment too. Tangent of 70 is 2.7474, so I'm going to round off to 75. Okay, so I get this. I'm going to plug that in. It should be a 2, not 7, sorry. 2.7475 equals 18 over y. Okay, now you're going to solve this like in a regular algebra problem. That's the good thing. So to get a variable out of the denominator, you multiply both sides by that denominator. Which gives me 18 equals 2.7475 y, and then I'm going to divide by the decimal. The 2.7475, divide 18 by 2.7475, and when I do that, I get y equals 6.55, and that's the answer. Now, you'll notice something over here. What happens when you do all of this, you actually end up switching the variable and that decimal because you multiply it by y and then divide by the decimal. So I'm going to write that middle step in right over here, that y equaled 18 over 2.7475. So that you can actually see that, what I did was between here and here, these two got switched. So it's a legal move to just switch the decimal in that y if the variable's in the denominator, from the left side to the right to the bottom of the equation. All right, I'll go through that a little bit more. I also thought I'd take a moment and show you what a trig table is for those people who don't have a scientific calculator. If I was looking, for example, for the tangent of 70, this is a trig table. I know they look like This is what we had to use when I was in school. Trig of tangent of 70. So these are your angles going down here and here, okay? And then I look for the appropriate column. There's 3 columns. Here's sine, cosine, tangent, and I'm looking for tangent of 70. So if I scroll down, you'll see I find 70 is here, and the tangent is this 3rd column, which means that's the number I'm looking for right there, the 2.7475. And notice that's the same number we got when we used the calculator, okay? If I was looking for the sine of, sine of 10, that would be, here's 10 degrees. Sine is the 1st column, so it would be 0.1736. So that's how you use a trig table. They're really not bad. You got to have a calculator after that to go, hopefully doing the multiplying and stuff. But anyway, I'll be happy to give you one of these in class, okay? So anyway, if you have a scientific calculator, one that has sine, cosine, tangent, one like this or something similar to it, I would recommend using that rather than the tables. It's got all the numbers in it for you. So you just hit either tangent of 70 or a 70 and then tangent, depends on the calculator. Okay, so that was that problem. I'm going to do another one of these. I'm going to call this problem 2. And I have the triangle like this. There's the right angle. Here's the x, here's 48, and here's 12. Okay, so the question says, just simply solve for x. And what you're going to do is start by identifying the sides of the triangle. Which one is this side here? Well, that's opposite the right angle, which means it's the hypotenuse. Which side is this one over here? Well, that's not the opposite side. That would be opposite. That means this must be the adjacent, okay? So I don't need the opposite one. Oops. So the adjacent and the hypotenuse, if you look back at your 3 ratios, the only one that has the adjacent and the hypotenuse in it is this one here, the adjacent. Sorry, the cosine. Cosine has adjacent and hypotenuse. So I'm going to use the cosine of 48. The angle always goes next to the cos, or sin, or tan, and that's the adjacent of the hypotenuse. And now I can plug in those 2 values. Here's the adjacent, and the hypotenuse is 12 over x equals the cosine of 48. And that is a equation that I can solve. Hit 48 and cosine in my calculator. Once again, make sure you're in degrees, not radians, which is equal to 0.6691. Okay, so I got 0.6691 equals 12 over x. And now you could either do my shortcut, switching these 2, or you could multiply by x and then divide by the decimal. X equals 12 over 0.6691, which is 17.93. Good, 17.93, and that is the answer. All right, next one. Have this be a you try. I want you to try this one on your own, okay? This is 30. Here's the right angle. This will be the x, and this one's going to be 6. Okay, so solve for x. And bring that into class. All right, next. What I'm going to get into next is the Pythagorean theorem, and I think this is usually a pretty easy one. I think most kids learn it in middle school. And it has to do with this equation, a squared plus b squared equals c squared. And this is only for right triangles. One thing that's crucial is you make sure you know which side is the hypotenuse, okay, in this case, because the hypotenuse has got to be C. It doesn't matter which one's A or which one's B, but it sure matters which one is C, okay? So you can draw that, you can put the formula on your formula sheet, and let me jump right in with number 1. So anytime I've got a right triangle with two sides, that is the time to use the Pythagorean theorem, okay? So once again, identify which side is the hypotenuse. That's this one, which means when I go a squared plus b squared equals c squared, x needs to be in for C, okay? So if I get that part right, the rest of it really should fall into place nicely. And it doesn't matter which one's A and B, especially in this one because they're both the same. 6 squared is 36, so I get 36 plus 36 equals x squared. 72 equals x squared. Therefore, x equals the square root of 72, not 27, 72, got it backwards. Okay, take the square root of both sides, remembering that the square root of x squared is x. Okay, now you do it one of two ways. You can either, if they ask for a decimal, you can punch in your calculator and give me, that the square root of 72 is 8.48. If they say, give your answer in radical form, that means reduce radical. Okay, so for example, I could break up 72 into 36 times 2, which gives me square root of 36 is 6 root 2, and there's the answer, okay? Or, if they ask for decimal, then x would equal 8.48. Okay, next one. So, go back to over here, got another triangle. Okay, so this is 13, this one's 5, this one's x. Okay, now, once again, make sure you get the hypotenuse correct. This one should be the hypotenuse, the 13. So when I plug in for A, B, and C, this has got to be C, okay? If you get that right, you will get the right answer probably. If you mess that up, I guarantee you'll get the wrong one. So 13 has to go over here. It doesn't matter whether the 5 goes in for the A or for the B, just not for the C. Okay, 5 squared is 25. 13 squared is 169. And now I'm going to solve it like a regular equation. Subtract 25 from both sides. And I get x squared equals 144. And I take the square root of 144, and I get my answer of 12. Just positive for this one because it's a triangle. I know that usually when you do that, you're going plus or minus on that answer because anytime you take that thing, but you can't have a triangle with side negative 12. Therefore, it doesn't make sense to use that answer in this case. Okay. All right. So number 3. Determine whether you can have, whether the given lengths can be sides of a right triangle. Okay, so like I told you before, the Pythagorean theorem is only for right triangles. And the three sides of this triangle were 15, 36, and 50. Which means if I take those three numbers and I plug them into the Pythagorean theorem and it turns out to be true, then it can be a right triangle. If I plug it into the Pythagorean theorem and what I get is not true, it's not a right triangle, okay? Now, which one is the hypotenuse out of those three? If you remember back, I told you that the hypotenuse is always the longest side of the triangle, which means the only number that could be the hypotenuse is the 50 because it's biggest. So that's going to be C. So if I plug that into my equation, I get 15 squared plus 36 squared equals 50 squared. And now we're going to use our calculator. 15 squared is 225. And 36 squared is 1296. And 50 squared is 2500. And now when I take 1296 and add 225, I get 1521. Does 1521 equal 2500? No, it does not. So that means not a right triangle. Okay. If it turned out to be like, 1521 equals 1521, then it'll be yes, it could be a right triangle. Okay, I'll write that over here. If it's true, it's a right triangle. If false, it's not a right triangle. All right, and that's how you do those. I'm going to do a U-try on that one. Here's Y, here's 17, here's the right angle, and here's 15. Solve for Y. All right, there you go. Do the Pythagorean theorem on that one. And I will close it out with a little bit more music. You guys have a great night.
One more time, I want to hear it from Jeff Beck, Carlos Santana, Eric Clapton, Billy King, Jimmy Bond, John Mayer, Robbie Randolph, Albert King, Mighty Waters, B.B. King.